Good morning. Welcome you all in today's online class. Today I am going to take a new unit in chemistry, that is unit 5, states of matter. Here unit 5, states of matter. In this unit we will discuss about the bulk properties of gases and liquids, like boiling point. It is not individual property of a molecule. Melting point is not individual property of a molecule. It is the bulk property. So, we will discuss about the bulk properties of these two states of matter, gaseous states and liquid state. About solid state, we will discuss in the 12th class. It is now in the 12th class. It is a complete unit, big unit, and you will study about that solid state in 12th class. Okay? So, come to about these three states. Take care, it is the bulk properties. We are knowing the different states of matter. We are basically concerned with these three states: solid, liquid and gas. Here the relation solid state, liquid state and gaseous state. And here is the solid state, and here the gaseous state. These are the three different states. First we know the phenomenon, well known to you, nothing new. When solid change into liquid, what we call the process? Solid change into liquid, the temperature is a melting temperature. This is the melting process, also called, one more name is given in chemistry, when solid is going to change into liquid at its melting temperature. This is called fusion process. Fusion process. At this in this process, heat is to be supplied to the system, to the matter, then only it is going to fuse. Heat is supplied, and when liquid is going to change into solid, this is called condensation, this is called solidification. Solidification process. Okay? And when liquid is going to change into gas, this is the one well known to you. It is a evaporation process. Evaporation. And when gas is going to change into liquid, this is called condensation process. The gases being condensed can be condensed into liquid, condensation. Whatever the energy change, energy change, we are knowing it. This is called fusion enthalpy, solidification enthalpy, enthalpy of evaporation, enthalpy of condensation. And here solid is going to change into gaseous state. This is called sublimation. And gases change into solid, that is called solidification again. Solidification process. the name of the process, solid into liquid, liquid into gas, gas into solid, and vice versa. This is the name of the process. And in this lesson, we are not concerned with the energy, we are concerned with the various properties and some mathematical relation between these three states. Okay? The reason behind these three states is why some matter they exist in a solid state, some of them are going to exist in a liquid state and gaseous state. The reason, interparticle forces, it depends on interparticle forces. Interparticle and intraparticle, these are the two different things. Interparticle means like H2O, water is a angular molecule, well known to you, and another water molecule H bond O bond H. Between two water molecules there is a kind of force of attraction that is called interparticle or intermolecular force. The different states of matter depends on interparticle or intermolecular force, and another force is called intramolecular. Intramolecular. Intramolecular force means the attraction, repulsion, whatever interaction within the molecule itself, between the atoms of the molecule, that is called intramolecular force of attraction. Can you guess which one is stronger out of these two, intermolecular or intramolecular? Generally, intramolecular force of attraction is much stronger. It refers the bond dissociation energy. It refers the bond energy of a particular covalent bond or whatever bond is there. And this interparticle force is a very weak force as compared to the second type of force. That is, these forces are very weak force, temporary force, not permanent, and this intramolecular force, they are the permanent forces. When a liquid boils, at the time of boiling, whatever force of attraction between the molecules, they are broken, and the molecule going to change into vapor state. At that time, only the intermolecular forces are broken, and here intramolecular forces, if you try to break H and O bond, it needs very high energy, that is not possible under normal condition. So, that is the difference in inter and intra, and the states of matter basically depend on interparticle forces or intramolecular forces. So, first here we will discuss about the different types of intermolecular forces, interparticle forces, which decide the state of a matter. Okay. When we talk about the arrangement of the particles in these three states, in gaseous state, the particles are far away, they must be kept in closed container, otherwise the particular gas will escape out. The particles are far away from each other, there is sufficient gap. The interparticle forces are very weak or it is negligible. That force is unable to hold the particles together, that is why they move freely in the system. While in liquid state, the particles are arranged in a systematic manner up to some extent. It is like that. They are closer as compared to the gaseous state. The interparticle force of attraction is strong enough to hold them together. That is why they occupy certain volume. Here the gases, they occupy total volume of the system. Here they occupy only the certain volume. This is the gases, gaseous state gas, and this is the liquid state. In solid state, the particles are well arranged in a systematic order. This is the arrangement of the particles in a systematic manner. There is much strong force of attraction between the particles, between the molecules, and they occupy definite shape, definite volume, and so many properties are somewhat different than the liquid and gaseous state. Their density very high as compared to the liquid, even very high as compared to the gases. They have higher melting point, boiling point as compared to the liquids. These are some specific properties. So, here we will discuss about the various intermolecular forces present in these three different states. Okay. Come to this topic, intermolecular interparticle forces. Interparticle forces. What are the different type of interparticle forces? One scientist, that is van der Waal, he gave the idea about the interparticle forces. Some question from you. Yes, Gaurav, definite shape and volume is the important for the difference between the solid, gas and liquid. Yes, it is correct one. So many properties are there which can differentiate these three different states. Okay. So, interparticle forces, the idea was given by the scientist van der Waal. See the spelling, van der Waals, V small, D small, W capital, van der Waals. He has not given the particular idea which kind of attraction is there, but he gave the idea of the interparticle attraction, van der Waal. That is why some force of attraction which was discovered by different scientists, in the honor of this scientist, these all forces are called van der Waal forces. Okay. These forces are, one is dipole interaction, dipole interaction or force. This is the one kind, dipole forces. The second is dipole induced dipole induced dipole forces, and third one is third type of attraction, dispersion forces. Third one is dispersion forces. These three forces, the idea was given by different scientists, but jointly these forces are named as, these three named as van der Waal forces. Van der Waals forces. In the honor of the scientist, in this lesson in gaseous state, he has modified ideal gas equation and gave a new relation, new equation, that is called van der Waal equation for real gases. Ideal gas equation well known to us, Pv is equal to nRT. This is for ideal gas, and in nature no anything is ideal. There is some discrepancy, some drawbacks behind that. So that van der Waal proposed a new relation, that he has modified that Pv is equal to nRT, that is called van der Waal equation. He has contributed a lot in different fields in chemistry. That is why in the honor of that scientist, the name of these three forces given as van der Waal forces, and two more forces are there. The one force is called ion dipole interaction, and another is hydrogen bonding, ion dipole interaction, ion dipole interaction, And the another one is, the fifth type is hydrogen bonding. Hydrogen bonding. Hydrogen bonding we have discussed in the previous chapter. It is discussed by the teacher. Hydrogen bonding, what are the consequences? Here also I am going to take some consequences of the hydrogen bonding. Okay, students. So, these forces we have to discuss in details. These are the different type of intermolecular forces. Okay. Let us take one by one. Dipole forces. This kind of force arises when a molecule is polar. Dipoles are there. The resultant bond dipole is also not 0. It has some value. That is why the molecule is polar, like HCl, HF, HBr, H2, like that. Here, see, this is the one molecule. Here is negative part, here is positive part. This is going to attract the neighboring particle, like here is the positive terminal, negative terminal. Actually, these positive and negative are partial, not complete. It is represented as del positive, del negative. If it is complete, then it becomes solid. That complete positive ion, cation, anion, it becomes solid, ionic compound. Here it is del positive, del negative. In this diagram, I have shown in this form positive and negative terminals of the molecule. This negative terminal is being attracted by the positive terminal of the neighboring molecule, and this kind of force is called dipole force. It depends on the value of del positive and del negative. Whatever the actual value, it is less than 1 unit positive or unit negative, but it varies, depends on electronegativity of the elements. Okay? HF, HCl, different electronegativity of the halogen. The dipole forces will be certainly different. If it is HF, here is hydrogen, here is fluorine, here is hydrogen, here is fluorine, and if it is HCl, hydrogen and chlorine. But the value of del positive, del negative will be different. The kind of force of attraction will also be different. And this force is strong enough to hold the molecule together, then they may exist in liquid state. Okay? Not only one force of attraction is responsible for the state of a matter. So many kind of forces are there. Jointly they are responsible for the states of the matter. Okay, beta, any query? London dispersion force is left. Okay, Tanmay, London dispersion force. Okay, beta. This dipole force, it was given by Kashyap. This is called Kashyap force. Out of these forces, 5 forces, one force is also called London force. This was given by this scientist Kashyap, that is why known as Kashyap force. Okay? So, this is the one kind of force of attraction between the particles. If it is in solid, this is in liquid state. Here the particles, another particles may be like this. In this way they are going to arrange here positive and negative, and here it may be like this. Here is a negative and positive. This is in liquid. If the state is solid, the particles are being arranged in this manner. Here it is like this. This type of arrangement is seen in solid state. Here is positive, negative, positive, negative, positive here, and here is this type of arrangement. This type of arrangement in solid state. Okay? That is the difference. In liquid, the particles are not arranged so properly as they are in solid state. but the force of attraction, this type of force of attraction is called dipole force, and the idea was given by the scientist Kashyap, also known as Kashyap force. Differentiate between inter and intramolecular forces. Just at the beginning I have told you what is the difference in inter and intra. Just once again you are asking, that is why once again I have given an example of water. Here is H2O molecule, angular, another water molecule, here is like this, angular molecule. Then between these two molecules of water, whatever the force of attraction between these two, that is called intermolecular. Inter means in between the molecules, in between the particles. This is called intermolecular force of attraction here, whatever the attraction between these two. And intra means within the particles, within the atoms of the molecule, the force of attraction is called intramolecular force, means attraction between hydrogen and oxygen. This oxygen and hydrogen means this is equal to the bond energy. This attraction between these two is called intramolecular force. Within the molecules, whatever atoms present, the attraction between them is called intramolecular force, and between two particles, between two molecules, intermolecular. Take care, in this lesson we are talking about intermolecular forces. Okay? Between the molecules, between the particles, whatever the kind of force, we are discussing about that. This force of attraction here in these particles, that is the intermolecular force. Here also the attraction between these particles are intermolecular force. The states totally depends on intermolecular forces. Okay? One question was given in the previous worksheet. H2O is a liquid, H2S is a gas. Why this comparison is done? H2O and H2S? H2O and H2S. There is a comparison between these two, comparison of some properties, states. This is liquid, this is gas. Why this comparison is done? The reason, oxygen and sulfur, these are the two elements belong to the same group, that is group 16, and the nature, the type of compound is also same. These are the hydrides of oxygen and sulfur. Okay? This is H2O, H2S, that why this comparison is done. Here the intermolecular forces between water molecules is stronger, which can hold them together in liquid state, that is why it is in liquid. And H2S, there is no such strong force of attraction, that is why H2S is a gas at room temperature. What kind of force? This is the one kind of force, this is present. Oxygen is more electronegative than sulfur, that is why the value of del positive, del negative charges are more in water molecule as compared to H2S. That is why this dipole forces is stronger in H2O than H2S. This is the one attraction. There are so many other attractions, and jointly they are responsible for the state of the matter. Okay, beta? I think it is clear to you. In this lesson, we totally discuss about intermolecular forces. Whatever properties we are going to discuss, relations we are going to derive, they are totally depends on the intermolecular forces. Okay. This is the one kind of force. It is much stronger in solid state as compared to the liquid. The second type, dipole induced dipole. Dipole induced dipole forces. Induced dipole forces. And this idea was given by Debye. Actually, Debye gave a small calculation for that, but basically he has given some other ideas about this type of force. Dipole induced dipole means one molecule is polar in the system, another is not, means we are having the mixture. then there is attraction, the gases are mixed together, liquids, two different liquids are there which can mix together, then what kind of force may be there? Means in this force arise when a matter is not pure, it is in mixture form, mixed form. Means one molecule, one particle is polar having certain dipole, and another particle, another molecule is non-polar which has no such dipoles. Okay? During interaction, they are going to interact together also. During this process, when the molecule come across, there is interaction starts, attraction, repulsion starts. Because of that, the distribution of electrons which was uniform, it is going to be disturbed because of this interaction, and this results into, here there is no change in this, but here the change takes place, and here this part becomes partially positive and electron density is shifted towards opposite side, here it is negative. This is called induced dipole. Actually it is not polar, but polarity develops due to interaction with this type of molecule. This is called induced dipole, and then they are going to interact somewhat strongly, and this kind of force is called dipole induced dipole force, that is also responsible for the states of the matter. And it depends on what are the factors? It depends on polarizability of this neutral molecule, its polarizability, and polarizability depends on the size of the molecule. If the size is large, electrons are away from the molecule, then it get polarized by this terminal. This terminal is going to affect the electron density, distribution of electrons around the nucleus. It get polarized, like fluorine, chlorine, both are neutral, both are non-polar, but polarizability of chlorine is more than fluorine. If you go for bromine, its polarizability is more than that. Therefore, this type of force arise in a neutral molecule and polar molecule, and it also depends on polarizability of the neutral molecule. If it is polarized easily, then this kind of force of attraction will be stronger in that type of system. Okay, students, am I clear to you? Third type of force is dispersion force. This dispersion force this was given by London. It was given by London in the year of 1930. This idea was given by this scientist. The first one is Kashyap force. This is given by Debye, not directly, but some idea related to this explained by Debye, and here it is given by Debye, we can write, and this is given by London. That is why it is also called London force. Okay. Dispersion force, what kind of force is there? In the previous examples, we have seen that both molecules are polar. Second, one is polar, another is not. And in the third type, when both are non-polar, then what kind of force of attraction is arise? In course of time, the electrons are not uniformly distributed around the nucleus. Because of some external factors, some external reasons, the distribution of electrons get disturbed for a short moment, and the molecule, this particle becomes slightly polar. Okay? This is not permanent, this is temporary only. This becomes partially polar, slightly polar, and here this disturbance in the electron distribution takes place. Here the electron density going to change in this way. Here the electron density is going to disturb in this way. this becomes a del negative, here is the del positive, here is a del positive, del negative. Partial polarity develops between the particles. This is not permanent, this is temporary only. Then there is attraction involved in these two particles. This is the attraction. This attraction was discovered by London in the year of 1930, and this is called a dispersion force. You can say that under what condition it is going to appear. Whatever the gases at room temperature, when they are pressurized and the temperature is reduced, they are going to liquefy, and when they are going to change into liquid state, some force is working between them, and that force is called here dispersion force. Like hydrogen gas, oxygen gas can be liquefied, even helium also can be liquefied. It has very low boiling point, that is near about 4.2 Kelvin. At very low temperature it can be liquefied, and at that low temperature this force of attraction is going to apply. It is going to appear at this adverse condition. Okay, bachcho? Any doubt, any problem? Definition, Ravi, which definition beta do you want? Side is not visible, Tejsi, I will take care. Which side is not visible? Okay, beta, Gaurav, yes, I will take care. Which definition do you want? Definition of these forces? The reason, if you are trying to define, try to understand the diagram, and with the help of diagram you have to make the definition in your own language. Okay? In books it is written very clearly, the definition part. If you understand the diagram and a concept, you can define it easily, and whenever it is needed I will certainly explain the definition, I will state the definition also when it is needed. I think these are simple, you can define in your own language, that is why its statement is not required. Here suppose in this way, what is the dispersion force? You are going to define it. It is a kind of force of attraction between the two non-polar molecules in adverse condition. In that condition, the electron distribution is not homogeneous throughout the particle, all around the particle, it is being disturbed. That is why it becomes partial polar and start attracting the neighboring particles. This type of definition we can write. Okay? So, this is the another dispersion force and the type of force of attraction. This appears in the gaseous molecules which are non-polar. Okay? Gases can be also liquefied, and when they are in liquid state, some force of attraction certainly there, and that force is called dispersion force. They do not have this dipole force because they are totally non-polar, no polarity is there. There is no dipole particle, all particles are non-polar, that is why the attraction is dispersion force. That is the third type of attraction. Okay, bachcho? Then fourth type of attraction is called ion dipole interaction. These jointly, these are called van der Waals force. So, sometimes we do not mention these individual forces, simply we write van der Waals forces. This is because of the van der Waals forces, and these van der Waals forces include these all three type of attractions. Okay? The fourth. The fourth type of attraction is ion and dipole interaction. Ion dipole interactions. This is another type. When ionic solid, ionic substance is going to interact with the polar molecules, polar solvent, polar liquid, then this type of attraction involved. Like when sodium chloride dissolves in water, when sodium chloride crystal is added with water, some interaction involved between these two, and because of that sodium chloride going to dissolve. That interaction is called ion dipole interaction. Ion of the solid get interacted by positive and negative poles of the molecule, that is the liquid molecule, and that interaction is responsible for its solubility. Let me take the example. Here is, these are the particles, here is Na positive, I am taking the specific example Cl minus, here is Na positive, Cl minus, here is a Cl minus, Na positive, here is Cl minus, Na positive, here is Na positive, Cl minus, Na positive, Cl minus. This is in solid state, hard solid having high melting and boiling point. When it is going to interact with water molecule, water is a polar molecule like this. Here is the water molecule, here is positive terminal towards Cl side, negative terminal outside. Here it is positive negative here with this, and because of this interaction, if it is strong enough, then this sodium ion can be kept away from this solid. Let me take that also. Here is the, because of this interaction, here is negative and positive, negative and positive, negative and positive terminals, and they are holding the sodium along together and taking them out, and finally this sodium is being changed in this way. This is the situation of the sodium ion. It is surrounded by a definite number of molecules, surrounding molecules. Here is a positive negative in this way, positive negative positive. This sodium ion is not going to attach again on the surface of the solid. It will remain in the liquid state along with the liquid. That is because of this interaction. It is surrounded by a definite number of liquid molecules, solvent molecules. They are keeping them away from the solid. In this way, solid going to dissolve. This is called hydration energy, and here is the lattice energy. Due to interaction, whatever energy involved here, this is hydration energy, and energy required to break this is called lattice energy. In this case, hydration energy supersedes the lattice energy, that is why it is going to dissolve. So, this type of force is ion dipole interaction force. Okay, students. And last type is hydrogen bond. Hydrogen bond. Before going to the hydrogen bond, let me take an example which is well known to you. In LPG cylinder, liquefied petroleum gas, which hydrocarbon is used? Okay, right side is not visible, this is this side. Students are unable to see that. Why is it so? They are asking, right side is not visible, that side. Okay, right side, this board side, my left side or right side? Which side is not visible? This date side or that side? Okay, I am going to take care of that. I will write it at the center only, not any side. Okay, LPG, well known to you, liquefied petroleum gas. Which gas is preferred? Praharsh, ethane, very good. Tanmay, butane, very good. And Subhashini, tell me the name of the substance. Butane, very good beta. Praharsh, it is butane. Why this butane is preferred? Not methane, ethane, propane. See that other hydrocarbons are methane, another is ethane, propane, and another is butane. Okay. Why butane is preferred? Let me take one more, pentane. Okay, which side? Some side is not visible to you. Pentane. These are the hydrocarbons, and we are preferring this butane for LPG cylinders. Do you know methane is a gas, ethane is also a gas, propane is a gas, and butane is a gas. That part is not visible. Butane is not visible to you. Okay, this part is not visible. Here is butane and pentane. This butane is preferred for LPG cylinders. Why is it so? Why not methane, ethane, propane? Because of this third type of force of attraction, that is dispersion force. In butane, dispersion force is much stronger as compared to the other molecules. Means dispersion force is also depends on the size of the molecules. Butane, there are 4 carbon atoms. Here methane, ethane, propane, 1, 2, 3 carbon atoms. When the 4 carbon atoms are there, these 4 carbon atoms, the surface area of the molecule is much larger, so that the dispersion force is become strong enough, and when we pressurize that molecule, it is going to change into liquid state. It is easily liquefiable gas. Basically it is a gas, but due to its large surface area, it has stronger dispersion force and it can be liquefied easily. That is why butane is preferred. Butane can be liquefied somewhat at lower pressure as compared to methane, ethane and propane. Okay. Its surface area is large and there is large dispersion force between the particles. That is why less pressure is needed. Why not pentane is preferred for filling the cylinders? Why not pentane? Pentane is having somewhat more large surface area. It has more dispersion force. Then why is it not preferred? The reason, pentane is a gas. Pentane, sorry, it is in liquid state. Liquid. It is in liquid state. That is why when we fill a liquid in LPG cylinder, then it won't come out, or if it is going to vaporize, then the rate of coming out of the gas is very slow and it is not going to fulfill our demands. Let me take one more thing here. I am taking pentane. Okay. These are the 5 carbon atoms. Okay. Hydrogen is needed or not? Let me write hydrogen also. Okay. CH3, CH2, 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 CH3. What is the name of this compound? Pentane. Okay. In common system, what name should be given? Because I am going to write the isomers of this compound. That is why its common name is N-pentane. Okay. Here the second compound, 4 carbon atoms in the chain, 1 as a side chain. This is called isopentane. Okay. Hydrogen we can arrange CH3, here CH3, here CH3, CH2, CH, having the same molecular mass. And the another isomer is this type of isomers you have studied in the previous class. Here it is CH3, 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 CH3. What is the name of this third one? Third one, what is the name? Third isomer? Gaurav, tell me, what is the name of this third isomer? Not IUPAC. In the same manner, isopentane, N-pentane, well known, not new, neopentane. These are the 3 isomers of pentane, N-pentane, iso and neo. Their boiling points are different. They are in liquid state, but their boiling point is too different. Much difference is there. Out of these 3, which has the largest boiling point, highest boiling point, first one or last one, and why? The reason, here the large surface area, therefore, the interparticle attraction, intermolecular attraction is maximum in this case, and here it is going to be changed into spherical shape. Its surface area is minimum, that is why its boiling point it will be minimum. The order of boiling point is like this. It is near about 36 degree, it is near about 23 degree, and it is near about 9 degree. This much difference in the boiling point. Okay, students, yes, you are answering correctly. The first one has the largest boiling point. The reason, it has maximum dispersion force. Dispersion force depends on surface area of the molecule. The surface area is largest, that is why there is maximum dispersion force. There is maximum chances of disturbance of the electrons. The electron get disturbed due to interaction between the neighboring molecules. That is why this force of attraction is maximum in this case, and it is minimum in this case. That is why the molecules having same molecular mass, same molecular formula, but boiling point are different. That depends on the surface area and kind of force of attraction working between the particles. Okay. So, this is the dispersion force. Now, come to the hydrogen bond, the last one, hydrogen bond. Okay. Simply, that's just you have studied in the previous class, hydrogen bond. What is the type of hydrogen bond? Like H2O, water is going to exist in this way. This is attracting the neighboring water molecule. Here it is like that. This type of force of attraction is called hydrogen bond, and this hydrogen bond is responsible for the boiling point of the molecule. For the different property, even state of the molecule is decided by this hydrogen bond. And here H2S is a gas, while H2O is the liquid. Its answer is based on hydrogen bond. H2O, oxygen is more electronegative, it has strong dipole attraction, it has strong interparticle force of attraction which hold them in liquid state. That is why it is in liquid, while H2S, it has no such force of attraction, it is a gas. Okay, students. So, thank you very much. The remaining part, that is the gaseous state, this is general discussion, then specific gaseous state we will discuss later on in the next class. Thank you, bachcho. Thank you very much.